Chris Roeder. I'm head of marketing at Pliant. Today, I'm joined by two colleagues who will be sharing the use case that we have promoted here today with all of you. Rob Cowart is the creator and co-founder, or creator and founder rather, of ElastiFlow, the only turnkey network performance and security analytics solution for data platforms such as Splunk and Elasticsearch. Rob has 2 decades of deep experience in modern real-time streaming technology and large-scale cloud deployments. I'm also joined by my colleague, Dave Hegenbarth. Dave is the Vice President of Systems Engineering at Pliant. Dave has over 25 years of experience helping people and businesses adopt new technologies like automation and orchestration. Rob, I'll pass it over to you.
Great. Thanks, Chris. So let me tell you a little bit about what we're going to talk about today. We're going to first dive into the ElastiFlow solution. I'll give you a brief overview of what ElastiFlow can provide for you, and then Dave is going to add to that by showing you what Pliant can provide an additional value on top of what we provide, in particular around security use cases. So I will start out by just, as I said, digging into the ElastiFlow solution a bit, and then I'll be passing off to Dave, and we have some demos along the way of both solutions. So who is ElastiFlow? Actually, ElastiFlow has a fairly, I'll say, humble beginning. As I tell people all the time, I'd love to tell you I had this master plan for the modernization of network traffic analytics. The reality is I kind of had this idea I played around with and threw up on GitHub, and it happened to resonate with people, and more organizations were looking to deploy it in increasingly large and production ready environments. And we discovered there was a need to take the beginnings of the solution and completely rework it to meet the needs of the growing demand we had. And hence was born at the beginning of this year, the ElastiFlow Unified Flow Collector, which we'll talk about in a bit more detail and what advantages it can bring. But let's first talk about the data that we're going to be looking at. So you may have heard the term NetFlow. So what is NetFlow? NetFlow is actually one of was the first technology where network devices could provide you information about the traffic that's traversing them. There are some other things as well, IPFix, S-Flow, and related technologies, but people tend to just kind of dump all of those under the category NetFlow when referring to it in general. And what this really is records that provide you information about which things in a networked infrastructure are communicating with which other things and over which protocols, and lots of more information than even we could fit on this slide. You could get information about class of service and VLANs and maybe application identity. Why did the session end? It really depends on what the vendor has provided in their implementation. We actually support out of the box about 6,500 such different pieces of information that vendors may provide in their flow data. And once you take these records, we process them, extract value from them. I'll show you a few details of that. And then we store that in what we like to call open data platform of your choice. So these are platforms that can ingest various types of information for various analytics use cases, like the Elastic Stack based on Elasticsearch, or Splunk. Logs.io is something we support, and similar. So what could you do with this type of data? Once you know like what things are talking with what other things, how can it be useful to you? So NetFlow really has 3 main use cases. The main traditional use case is around performance and availability. If you think of a lot of types of network metrics, things like S&MP, more recent systems, different streaming telemetry technologies, they may tell you something like, your uplink to the internet is 85% utilized. However, the question you immediately have after that is, well, what's driving that utilization? Is it a particular server or application? Is a particular user, maybe watching too much Netflix during their workday, right? And so what flow data helps you to do is understand the breakdown of the traffic that you're observing. The other use case that is very much, I would say, really driving the push and interest in flow data, and is going to be the conversation for most of the rest of our webinar here, is the security and compliance use case. So if you know which things are talking to which other things over which protocols, et cetera, you could do lots of different types of interesting analytics. For example, if I see a really high number of unique DNS server source IP addresses that are responding back to me. So I have a source port of 53 and I have a whole bunch of IP addresses. That looks suspiciously like a DNS amplification attack. Or for example, I have repeated connection attempts to a CLI type port like SSH or Telnet, which we'll dig into a bit later. And I see those repeatedly with a certain pattern, then that could be a type of brute force attack. And so when we understand the traffic traversing the network and can analyze that, you can do lots of interesting security type determinations. And the final thing is cost control. This is generally one that I would say is some of the more mature users of flow data. It's really helping them to understand the traffic patterns in their network so that they can optimize their network architecture decisions to help them save cost or determine where they might have opportunities to do so. So what ElastiFlow provides is what we call the ElastiFlow Unified Flow Collector. So unified in that it supports all the major types and versions of flow data out there. So like NetFlow version 1, 5, 6, 7, 8, 9, and then IPFix and a couple versions of SFlow as well. We process and extract the maximum on information out of those records that we can, including enriching it. One of the more interesting things around security is a partnership we have with a company called RiskIQ that was recently acquired by Microsoft a few months back. And they provide a threat intelligence feed so that we can actually provide IP reputation type information to the traffic traversing that you observe traversing your environment. And then we send that data to one of many different platforms that we support. We also provide you the other elements you might need for that platform, like dashboards, alerting, and those type of things that you can simply import into the platform and therefore transform it instantly into a powerful network analytics solution. I mentioned Elasticsearch, so that we're going to really focus on that today in the demo part of it. So we're sending the flow records to Elasticsearch, where we support not only on-prem deployments, but also if you need like flow data as a service, we'll also support Elastic Cloud and even their Kubernetes-based deployment. So pretty much any flavor of it that you happen to be using or would like to use in your environment. And some of these variants that Elastic provides have some additional features that we help you take advantage of, such as their machine learning technology and some of the alerting capabilities as well. What really makes, though, our collector different and thus the heart of the solution is our approach to processing that flow data. So there are a lot of things out there either from other vendors or from in the open source world that have a very basic collection and parsing of flow data. We like to take that a step further, and not only the vast number of fields and complete set of data types that could be sent that we support, but we also believe that our users and customers don't want lots of specialized dashboards and things and lots of specialized analytics per vendor, per device type, et cetera. So we put a lot of work into normalizing that data so that analytics can be applied to it universally across the very heterogeneous set of devices. We also do what we call translation. So the easiest way to explain translation is that some people that have been doing networking for a while, they may immediately off the top of their head just know that, IP protocol 17 is UDP. But do they know that 132 is SCTP? Actually, now I'm confused. Is that DCCP or SCTP? And 33 is the other one. But so you can see there's a lot of different heavily encoded, enumerated type of values and network data that you really need to pick apart to grab the maximum on information out of it. We have actually over 400 of those translators, as we call them, to help turn that data into something that's more easily consumed by network operators. And then finally, there's enrichment, which can be external data sources that we use to further decorate those records that we're storing so that you have the ability to perceive them from various different perspectives that you care about. But what we also would consider under that umbrella of enrichment is where we look at various different fields within those records we receive to derive new information. So a great example of this would be how we look at certain combinations of packet counts, TCP flags, and a few other elements to infer, do we believe a layer 4 accession has been established by the traffic represented in this flow record? That can be really great to simply filter on a small subset of the data that you'd like to focus on. And so that's those things of normalization, translation, and enrichment are really what we feel separates us from a lot of the other solutions out there. Now, once you've taken this data, and as I said, we put this in this case like into a platform like Elasticsearch. We provide all the dashboards and other artifacts you might need to further analyze that data. Of course, in the security context, there's a few things that allows you to do. There's typical kind of threat hunting, which is using the dashboards to dig into the data set and drill down in and identify things that may be of interest to you. But you could also do some more static alerting rules to kind of automate part of that. For example, and this comes back to my established session enrichment we talked about. So I might do something where I say, if I have a public IP address that is attempting to connect to a database port that is on one of my public IP addresses, and it looks like a session has been established between those two endpoints, then I'm going to say that's a compliance violation, database access from outside our environment, someone needs to take action. The other type of analytics is a bit more, I'll say flexible than more static rules. It's using anomaly detection methods. In this case, we leverage the machine learning engine that's inside of the Elastic Stack, and we provide a whole suite of analytics jobs, some anomaly detection jobs that will look at that underlying data and will identify anomalies. And for example, one of them might be a port scan. So what's a port scan? It's when one particular client is trying to access a bunch of ports on a server. And we can do a population analysis there and say, does one of these clients look different than the others? In other words, is its behavior different than the other clients? If it's accessing a very large number of unique ports, then it's different, and that looks like a port scan. And so we can take that type of reconnaissance and alert you on it. And then we'll dig in here in the demo into another example of what the results of that anomaly detection could look like for a different security use case. So let's go ahead then and jump into a demo of the ElastiFlow solution. Get my mouse down here. There we go. So as I mentioned before, so the collector is sending the data to Elasticsearch, and there is, and we have a suite of dashboards that you can import in to begin to visualize and analyze that traffic. So this is what we see here is the primary ElastiView overview dashboard. You will see in the lower right, you get some of the IP reputations that are being seen within the data set that we have. That's based on that RiskIQ IP reputation or threat enrichment that we provide. And just a various number of other fields here to give you an overall view of the traffic that's in the environment. You could already start here to drill down and to see various things that you might be interested in. So for example, maybe I just want to know who's connecting to SSH. So we can select SSH out of that data set, and I can immediately start to look and see, interesting that there seems to be a lot of, we have one server here that's being accessed pretty heavily by this particular client. I could further drill right down into that pair of devices and even switch from that dashboard over here to the flow records because I want to view those raw records. And I see all of the attempts from that client to this particular host inside my environment over SSH, and quite a few, quite a bit of traffic that's going between them. Also interesting is over in the first column where I see the different devices, I actually see my router here is telling me about that those flows, but I also have a firewall that it's going through that's also telling me about those flows. And so that's kind of an example of just using threat hunting techniques to look for something that you may be curious about in the user interface. In general, there's a lot of different dashboards that provide different perspectives of the traffic underneath. typical things on flow data are looking at like top in, where we want to see, top clients or servers, or either other perspectives like, what are some of the top applications in the environment that, just allow us to break down the traffic based on various categories. Uh, Assuming that the flow data actually provides it, you could even get information about VLANs, class of service like DSCP values here, even TCP flags, TCP options that might be set on any of the traffic, as well as understanding as traffic passes through your network devices, where, for example, I might want to say, let's take a particular switch and, we want to look at a particular ingress interface maybe. Actually, let me go to this router. That'd probably be a better one. We'll go to this router here, and maybe we want to see inbound from the internet type of connectivity. So we're looking at that ingress interface, and I can see there's 3 different interfaces where traffic is going egress. Interesting spike right there. That might be something I'd want to check out. And you do that simply by setting various filters and switching in context to the different dashboards to analyze that information, right? For the sake of time, I will then move back over to talking about that SSH traffic we looked at earlier. So while it's nice to be able to click around on a dashboard and set filters and drill down in context, you don't always want to have a human that spends their full time constantly having to look and keep an eye on things. Ideally, you want to be able to automate that analytics with some type of more intelligent processes that can process, millions of flow records and identify the proverbial needle in a haystack out of all of the information that's in the system. One of the ways you can do that is with Elastic's machine learning engine and the machine learning jobs that we provide out of the box that users can simply import into the Elastic Stack and enable them and automate analytics. You'll see there are some things that are kind of performance and availability related. We have tags set for those, and a number of things that are very security related, a bunch of different types of amplification attacks, some recon type activity like port scans. Quite interesting, like some things like unusual or rare autonomous systems. There we are right up here, right? Or rare conversations. This would be looking at things talking to each other that is really uncommon for the environment. If you think back to the sunburst attack that made the news all over about a year ago, a supply chain type of vulnerability that caused a lot of people's data to be accessed. The interesting part about that is all of that data was sent to a single domain. And it should have been pretty easy by this type of analysis to recognize that rare traffic that was occurring and flag that as it just started so that it could be further investigated. Those particular attacks might have been detected in a matter of hours or in most days as opposed to months, right? So I'd like to go back to the brute force attack. So one of ours is a brute force login attack. We can, if we drill down into that particular job, we can see, I'm going to switch over here to look at it from the perspective of clients. So we have the different clients, and we're going to look at this most recent window of time here. So here in this recent window of time, we do have an anomaly. These different colors show the severity of the anomaly or how anomalous is it. And we can see that the machine learning has said, yeah, this particular IP address, this client is acting quite differently than the others, accessing a large number of ports compared to others. We can actually see there's a few different ones in a few different windows. It's analyzing the data window by window of time. And we're like here at a couple hundred attempts where we might usually expect a normal value to be 1. So there's a number of things I can do from here. So there are URLs that are configured that allow you to use the information out of that machine learning job for various tasks. One of them could just be to jump from this anomaly back into the dashboard that has the raw data. So I can look at those raw records and we can see when that started happening. The other thing, though, that we could do, and this is quite important for this conversation, is we have a piece of information here, which is an IP address. So it would be great if I could simply say, this doesn't look good to me. I'd like to shut down this IP address and block it from accessing my systems. So what we've done here is we have set up a URL. So we're accessing an endpoint. In this case, it happens to be from our friends here at Pliant. And we have the ability to hit this link and block the IP address. Now, I'm not going to tell you about those details, and I'm not going to click the button yet. We'll come back to that. But I'm going to pass off now to my friend Dave and allow him to share with you a bit about how Pliant would then take this message from us and take action. Mute, Dave.
Thanks, Rob. So yeah, it's amazing the volume of data Flow generates, right? It's very verbose, and it has a lot of applications, in the security one being a really critical one for organizations. And as you watch Rob run through those screens, it's certainly something that SecOps people do, right? They go through screens, they take a look at anomalies, and they perform actions. But as Rob alluded, wouldn't it be even nicer if sometimes when the severity is very high, it's a very rare occurrence that this particular traffic should be flowing in the manner it is, that we take some sort of action. And Pliant's role is helping enterprises, service providers, and our partners like ElastiFlow to build automation that dovetails into that. When an event happens, we want to take action, and we don't want to spend months and months writing scripts. So Pliant is a low-code, no-code automation platform from which you can write automation. You're going to see in the demo in a minute, we're going to take an inbound web request or a webhook, and we're going to do some pretty cool automation. And all of that is generated from the Pliant platform itself. Pliant serves a large part of the IT infrastructure community as a secure platform, which you can build and run automation on. So these are some of the buckets that we play in. You'll see anything from security to ITSM, infrastructure to cloud. And we also consume already created automation. I'd never argue that, drag and drop automation is easier than automation already built. So if you have an investment in Ansible, Terraform, PowerShell, things that you've done to already begin to automate your environment, you can actually bring those into the secure platform of Pliant, wrap role-based access control and high availability around those, and still use the automation that you've built. Part of the intellectual property of Pliant is just this. For over 100 some odd different vendors, we've gone out and taken their API endpoints and turned them into action blocks. So what you see on the screen here on the left is a way of writing code, right? If you wanted an automated response to some particular event, you could pop open Node.js, Python, or your favorite programming language and begin to type away and wrap code around a user or an end user and enterprise's API endpoint and take some sort of action. At Pliant, we try to make that a whole lot easier. So we've taken about 100, as I said, 100 plus vendors worth of API endpoints and turned them into the block that you see on the right, or an action block. And when we do that, we try to add really 3 points of value. The first is, you'll see the little green A there, and that represents the authentication. So we've handled authentication. We've wrapped role-based access around it, such that when your coders actually use the Pliant platform, they can use a tag. You don't necessarily have to divulge the root password to something. You're going to actually instantiate that authentication in our password vault, and then hand your automation builders a tag that they can use. Secondly, we wrap all the debug information we can get. What we've seen is a lot of times when people are in a hurry to write automation to respond to an event, rarely do they write any debug code in their lines of code that they're building in Node.js or Python, because it takes time, and we have to try to figure out what those pieces would be built into these blocks as you drag and drop them on the screen. And I'll show you that in a minute. And then lastly, you'll see in the body of this block some well-formatted JSON text. But that comes from another part of our product where we actually give you an HTML form that displays every parameter for an API endpoint. So most API endpoints, in this case, the block was actually designed to create a virtual machine in AWS. We could be cloud, we could be on-prem, we can be firewalls like Palo Alto's, or we could be security groups in AWS. But the key point is, as we bring in that vendor's API endpoints, we also enumerate any of the parameters. So if you were to build a virtual machine, you want to know, like, what type of instance is this going to be? How many CPUs? How much disk space? All of that gets baked for every endpoint. And we have about 500,000 endpoints now in the solution. Every endpoint, we enumerate the parameters. Why do we do this? Because it helps you build your automation faster. We drag and drop the blocks on. And even if I'm not clear on how to build a virtual machine in AWS via the RESTful endpoint, I now have this block that allows me to ask, it asks me questions that I just fill out, and then I can execute this. So I think what we'll do is we'll take a little look at what that looks like in our actual product, so I can do just a bit of a demo as well. So again, the Pliant platform, a secure place to run any type of IT automation. In this case, what we're going to do is we're going to take an inbound request that there's been from ElastiFlow, an inbound request that there's been some sort of intrusion, and there's an IP address that we want to block. How do we do that? Well, in our drag and drop sort of interface here, you can see that I actually have a workflow that's going to be called. And the first thing we're going to do is figure out whether the endpoint device, in this case, the 40net firewall, is API enabled or not. If it is, we can use some drag and drop blocks that you see on the right here. I'll go down to the 40net suite of blocks that we have here. And we're going to use these the firewall rules to actually make or change a particular config. These are all the different endpoints that we support for this particular vendor's platform, the 40net platform. Now, there are also devices in the infrastructure, as I'm sure you're all aware, that are legacy devices. They don't have a nice API formatted for them, and that's not a problem either. So in this case, if it's not API enabled, we're actually going to use a series of CLI commands to do that. And here's the flow that's actually going to get called for our slightly older firewall that doesn't have one. So we go through and we assign an IP mask to the rule. We're actually going to come down and make a firewall rule. And you can simply drag and drop these blocks onto the screen. And for any given block, I can come over to the right here. I can open this block and we can see the actual code that's going to get executed. So I'm literally going to CLI, command line, firewall address, edit the Pliant rule, and then I'm going to go to my next block. And after that, I'm going to assign the mask. I'm going to set a color to this. I'm going to associate the interface, so forth and so on. And at the very end here, I'm actually going to send Rob and myself an email to let them know that this automatic action has been triggered. So again, Pliant is a low-code interface for over 100 plus different IT vendors that allows you to drag and drop your way to doing some really cool and important automation, right? We're under attack and we want to block an IP address, and we don't want our users to have to do that. We can actually work with our vendors and our partners and large enterprise and service provider to take those events and then take appropriate action. And we let our users build that appropriate action very quickly in these workflows. So I'm going to send it back to Rob to let him show you what this looks like in action.
There we go. Had to get the right one. Thanks, Dave. That was really interesting. The part I like about that too is also where you have that bit that kind of says, hey, is this one of the new ones that supports this, or is this still an old one that doesn't yet support? And just having that flexibility to make those workflows a bit more adaptive, right? So we talked about this little our little button here, this block IP. So the first thing I'm going to do is I'm going to go ahead and kick this off. We're gonna block our IP address. It actually calls an endpoint and the Pliant endpoint, and I'm passing in that IP address as an argument. As that goes off and runs, actually, there we go. We have our response back, so we can close that window. In fact, I just saw my phone light up next to me here on the table, which means we got an email too. We'll look at that in a second, as Dave said. So what I wanted to show you is that kind of does its work and the results start to show up. Is what we've actually done here is when I go in and configure this job, I have these custom URLs. So what's really great about Pliant is you can have, from our perspective, is if you have all of this data or all of this logic in these workflows, I don't really have to worry about what that logic is. All I'm doing here is I'm basically taking that URL and I pass in, there's a variable down here where I'm basically passing in the IP address that I want to be blocked. At that point, I'm just passing that on to that endpoint, and the Pliant platform goes about taking the actions that have been configured as part of that workflow. So one of the things, so here was our device, obviously a very simple configuration for the sake of this demo. I had hit the button there, so the Pliant system will have done its job if I refresh that screen. And we see here, we now have this deny that happens to be on the IP address. Hopefully, I know that's a little small, but you should be able to see that hopefully that IP address matches the one that we were getting the SSH attack on. I also did receive the email here that Dave mentioned. So he added a policy, and that email address was blocked right there. And perhaps even more interestingly, and we have to give it a second, the flow data typically can lag the real traffic about a minute or so. So what I did is I previously had set up a filter here for this traffic that we know that we have coming in. And we'll give it a couple, it takes about it refreshes every minute here. So we'll look at it in a second. But what I wanted to show is if you look here at, the to and the from, and we have these TCP flags, is kind of interesting because here we see like a syn ack finish thing. So this is essentially connect to the SSH server, try out a password. The server says, nope, that's wrong, and dumps you out, right? And so there's been clearly the whole handshake established and what have you. And now that traffic is being blocked, we will start to see here. I tried to fill the gap of time. Actually, we can already see, look, the number of flow records down here dropping considerably to that particular device. And what we're going to look for here is we should also see the flags just show like a SYN, maybe a SYN PSH, or maybe there's an ECE in there. But basically, we're not getting the acknowledgements, which means that the SYN packet's being blocked by the firewall. It's not even making it to that end spot. And essentially, the person trying to log in no longer gets a login prompt, etc. So, wow, I thought I had my timing out just perfectly, but give me one more. I want one good SYN pack without an ACK in there. Anyway, we've seen the drop off. There we go. Not quite. Okay. We see the drop off in flow rate though, which is, all of those packets that aren't being handed off back and forth after blocking that. All right. So that is it from the demo side. I would pass it back to you, Chris, to kind of open things up for any questions there might be.
Perfect. Thank you, Dave and Rob. Appreciate you walking us through this story. For the folks who are on the webcast, there is a Q&A option if you wanted to ask questions of the presenters, and there are a few in here. So I'll go through them here in just a second. But I did want to make mention of a couple things. One, this webinar will be available on demand to any of the folks who attended or registered. And we do appreciate you taking the time out of your day to be here with us. If you do have questions or would like to learn more about Pliant, ElastiFlow, or our integration together, you can reach us at pliant.io or elastiflow.com. So, okay, let me go into the Q&A here. This first question is from Bruce. And the question is, how hard was it to build the demonstrated integration?
Yeah, I think from my side, it was super easy. Again, the idea is the drag and drop. And then I think Rob will agree. I won't speak for him, but one of the neat things is once you create automation in Pliant and you click save, you just pull some blocks over and click save, we automatically generate that RESTful endpoint that I handed Rob to put into the ElastiFlow solution.
Okay.
Well, and as I mentioned also, I mean, like I said earlier, for all I really had to worry about is what is the endpoint Dave gives me. So it was really pretty straightforward. And again, that reusability, as Dave mentioned, is really the key, that you can have these blocks that you just, reuse for multiple different use cases. They may be applicable one way or another. So yeah, for us to add the endpoint for the URL was literally a small 30-second change over what we had already had in our solution anyway. So pretty simple.
Okay. Thank you. So we have time for just a couple more questions. The next one is a little longer. Typical workflow is to null route or black hole route a network when we see malicious traffic coming in from specific IP space. We often get alerts of this type of traffic from ElastiFlow today. Can Pliant help us automate this process to add a particular route with the enriched prefix from that ElastiFlow/risk IQ to our black hole router? Part two of that question, can Pliant also connect to ServiceNow to help automate the trouble ticket for this process?
So let me give one piece of information, and I think this is mostly going to be Dave's answer. But Dave, by the way, one of the things that we do have, especially as we enrich with autonomous system information and what have you, is the routed block of IP addresses that that like in a given IP address, the public routed block that IP belongs to, so that you could take action in theory on an entire CIDR and not just an individual IP address.
Yeah,
I'll let
and
you
that's
take from there,
perfect. Like
Dave.
I was going to mention even before in the other conversation, we can take any number of different variables passed to us. So it wasn't just IP address. You could pass all of that information into Pliant. And then because we cover off so many different vendors from, Palo Alto to Fortinet to, security groups in the cloud to routers and switches, we have the ability to drag and drop that automation to do exactly that use case.
Okay, thank you. We'll just see if we can squeeze one last question in here, and this is a brief one, and it's relatively open-ended. It asks, are these solutions on-prem or cloud? Maybe you could take a swipe at that, Rob and Dave.
So on our side, there's two parts of the question from our side. One is our collection technology itself, and the other is the platforms that we send data to. Now, most of the platforms we do send data to are available in both SaaS offerings, like with Elasticsearch, I mentioned earlier, Elastic Cloud, and we support all the different ways to authenticate with those cloud platforms. Our collector as well can also be run either native install. You could install it in a VM, run it in a Docker container. We really love Docker containers, I have to admit. So I view it as the easiest way to install, upgrade, and otherwise maintain the solution. But we really believe in freedom of choice in that regard, and we try to provide you all of those options.
I think also, yeah, Pliant as well as, the world evolved around us. We have the ability to be an on-prem solution and in the cloud solution, or again, our architecture lends itself to a hybrid solution where the analytics, the automation happens in an interface that you can access via the cloud, but the actual API commands, if they necessarily need to run on-prem, can be done via what we call a remote worker. And that remote worker software, again, can be a VM. It could be a container that runs on top of Docker. So there's a myriad of different ways to deploy this. It's really up to the enterprise how they want to do that.
Excellent. Well, with that, I want to thank everyone on the call for taking the time to be with us today, and to Rob and Dave as well for leading this conversation. We'll reach out to you with a link to the on-demand version of this webinar. And again, if you have any questions, please reach out to us at pliant.io or elastiflow.com.